Artificial intelligence, or AI, is becoming a bigger part of our daily lives. We find it in many places, from our smartphones to our workplaces. It helps us search for information online. It suggests movies we might like to watch. Companies use AI to improve their services and create new products. This technology seems to promise a future filled with amazing advancements. It learns and adapts, changing how we interact with the world around us. The growth of AI is happening very quickly. This rapid expansion of AI is exciting for many reasons. It brings new possibilities to fields like medicine, transport, and entertainment. AI systems can analyze large amounts of data much faster than humans. This can lead to new discoveries and more efficient ways of doing things. The potential benefits often dominate our conversations about this technology. We hear about smart cities and personalized healthcare. However, this focus on benefits can sometimes hide other important aspects. Beneath the surface of these digital wonders, there is a hidden environmental cost. Developing and running AI systems requires a huge amount of resources. This includes energy for power, water for cooling, and materials for hardware. The silent hum of servers in data centers supports every AI query. This constant activity has a real physical impact on our planet. It is an impact that we are only just beginning to fully understand and measure accurately. It's crucial that we start to talk more openly about AI's environmental footprint. Understanding this hidden cost is the first step towards responsible innovation. We need to ask difficult questions about how AI is made and used. We must consider the long-term consequences for our environment. Only by acknowledging these challenges can we hope to build a future where AI technology and a healthy planet can coexist. This essay will explore these hidden costs in detail. Artificial intelligence systems need a tremendous amount of electricity to function. This thirst for power is a major environmental concern today in 2025. When AI models are being trained or used, they consume significant energy. Much of this energy still comes from burning fossil fuels like coal and gas. The burning of these fuels releases carbon dioxide, or CO2, into the atmosphere. CO2 is a primary greenhouse gas. It traps heat and contributes directly to global warming and climate change. The scale of AI's energy use is becoming clearer. Recent research has revealed some startling figures about AI's energy consumption. A study that analyzed 79 major AI systems between 2020 and 2024 projected alarming emissions. These systems could collectively emit over 102 million tons of CO2 annually. This is a massive amount of pollution entering our atmosphere each year. If we put a price on this carbon, say $109 per ton, it could cost the AI industry over $10 billion every year. These numbers clearly show AI's substantial carbon footprint. The global demand for electricity from data centers, which power AI, is soaring. In 2022, data centers worldwide consumed about 460 terawatt-hours of electricity. Projections indicate this figure could skyrocket to 1,050 terawatt-hours by the year 2026. This means consumption could more than double in just 4 short years. If this projection holds true, data centers would rank as the 5th largest global electricity consumer. This puts AI's energy needs into a global perspective. This escalating energy consumption poses a serious challenge to our climate goals. As AI models become more sophisticated and larger, their energy demands often increase. For instance, the emissions from training the AI model GPT-4 were found to be 12 times higher than its predecessor, GPT-3. Google's Gemini Ultra model was identified as a significant contributor, accounting for 36.7% of emissions in one study. It is vital to develop more energy-efficient AI and power sources. Otherwise, the environmental burden of AI will continue its rapid ascent. Data centers are the physical backbone of the digital world, including artificial intelligence. These are not abstract clouds, they are huge real buildings. They are packed with rows and rows of powerful computer servers. These servers store, process, and transmit the vast quantities of data that AI systems need. AI cannot learn, think, or generate responses without these immense data fortresses. As AI use grows, so does the need for more and larger data centers across the globe. This expansion has significant implications for resources beyond just energy. The growth in North American data center power requirements illustrates this trend starkly. Between 2022 and 2023, their power needs nearly doubled. They increased from 2,688 megawatts to 5,341 megawatts. This surge is largely attributed to the escalating demands of AI. Globally, the sheer number of data centers has also exploded. There were around 500,000 data centers in 2012. By September 2024, reports indicated this number had climbed to an astonishing 8 million. This rapid construction places new pressures on land and local infrastructure. Beyond electricity, data centers are also incredibly thirsty for water. This water is primarily used for cooling the densely packed servers. These machines generate immense heat as they perform complex calculations for AI. It's estimated that data centers can use around 2 liters of fresh water for every kilowatt hour of energy they consume. This heavy water usage can severely strain municipal water supplies, especially in regions already facing water scarcity. This competition for water can impact local communities and fragile ecosystems. The concentration of data centers in certain areas highlights these resource pressures. In Ireland, for example, data centers are projected to consume nearly 35% of the country's total electricity by 2026. This is a staggering proportion for a single industry. Sometimes, to meet urgent demands, new data centers are rapidly constructed. They might initially rely on fossil fuel-based power plants, further increasing emissions. It's projected that AI-related infrastructure could soon require 6 times more water annually than the entire nation of Denmark. This illustrates the colossal scale of resource consumption involved. The training phase is where an AI model learns to perform its tasks. It involves feeding the model enormous data sets. This process is like sending the AI through an intensive schooling period. It requires immense computational power. Powerful computers must run continuously for days, weeks, or even months. They perform countless complex calculations to adjust the model's parameters. This initial training stage is exceptionally energy intensive. It creates a significant carbon footprint even before the AI model is deployed for practical use. This upfront energy investment is a critical part of AI's environmental story. Let's consider a concrete example to understand the scale. Training a large language model, such as OpenAI's GPT-3, an older but well-studied model, consumed an estimated 1,287 megawatt-hours of electricity. This quantity of electricity is substantial. It is enough to power hundreds of homes for an entire year. The carbon dioxide emissions generated during this single training process were estimated at 552 tons. This is comparable to the annual emissions of over 100 gasoline-powered cars, and this is just for one model during one training cycle. The specific energy demands during training are a major concern. Generative AI training clusters, which are groups of computers working together, can consume 7 to 8 times more energy than typical computing workloads. This means these AI training setups require a much higher concentration of power, known as power density. This high power density can place a significant strain on existing electricity grids. In some instances, the local power grid may struggle to meet these fluctuating and intense demands. Data centers might then resort to using on-site diesel generators, which are highly polluting. Another troubling aspect is the relatively short operational lifespan of many AI models. The field of AI is advancing at a breathtaking pace. New, larger, and supposedly more capable models are constantly being developed. This rapid pace means that older models can become obsolete quite quickly. The considerable energy and resources invested in training these previous versions are then effectively wasted. It's akin to investing heavily in a tool that is discarded shortly after its creation. As future AI models are anticipated to be even larger and more complex, their training energy requirements are set to escalate further. Section 5. Constant current, the operational energy footprint. Once an AI model has completed its intensive training phase, it enters the operational stage. This is also known as inference. During this stage, the AI performs the tasks it was designed for. This could be answering user questions, generating images, translating languages, or making predictions. Many people assume that training is the most energy-consuming part of an AI's life cycle. However, the cumulative energy used during the operational stage can far exceed that of training over time. This is because a popular AI model is used millions or even billions of times by users worldwide. Research findings highlight the surprising scale of operational energy demands. It has been estimated that the annual operational emissions of an AI system can be around 960 times greater than the emissions from a single training run. This is a crucial distinction. While a single training event is very energy intensive, the day-to-day continuous use of the AI model by many users adds up to a much larger energy toll over its lifespan. This ongoing energy consumption is a significant and often underestimated part of AI's total environmental impact. Every single interaction with a generative AI model consumes energy. Each query sent to a chatbot like ChatGPT or a request to an image generator requires computation. This computation uses electricity. Estimates suggest that a single generative AI query can consume about 5 times more energy than a standard Google web search. Now, consider the millions of users interacting with these AI tools multiple times every day. The total energy consumption quickly escalates. This daily widespread use by individuals and businesses contributes significantly to AI's growing carbon footprint. The trend in AI development is towards increasingly larger and more complex models. These next-generation AI systems are expected to handle more sophisticated tasks and provide more nuanced responses. However, this increased capability will likely come at the cost of even higher energy consumption for each inference or query. This continuous and growing demand for power during operation means that AI's environmental footprint will keep expanding. Unless we can innovate more energy-efficient AI algorithms and hardware and use these tools more judiciously, the operational energy burden will become an increasingly pressing global issue. Section 6: From Mine to E-Waste. The material life of AI hardware. Artificial intelligence cannot exist without specialized physical computer components known as hardware. Graphics processing units, or GPUs, are particularly crucial for AI computations. They act as the powerful engines that drive AI systems, enabling them to process data at high speeds. Major tech companies like NVIDIA, AMD, and Intel are key producers of these GPUs. The shipment numbers for GPUs to data centers are rising dramatically. For instance, shipments rose from 2.67 million units in 2022 to 3.85 million in 2023, with more increases expected. This surge reflects the booming demand for AI capabilities. The manufacturing process for these high-performance GPUs is inherently energy-intensive. It requires more power than producing simpler central processing units, or CPUs, due to more complex fabrication steps. The overall carbon footprint of a GPU, however, extends far beyond its manufacturing energy. We must also account for the emissions from sourcing the raw materials needed to build them. These materials are often mined in one part of the world, processed in another, and then the final products are transported globally. Each step in this complex supply chain adds to the hardware's environmental burden. AI hardware depends on a range of critical minerals, including various rare earth elements. The extraction of these minerals is often an environmentally damaging process. Mining operations can lead to habitat destruction, soil erosion, and water pollution. Many mining practices are unsustainable and can have severe impacts on local ecosystems and communities. To illustrate the material intensity, producing a typical 2-kilogram computer can require the excavation and processing of approximately 800 kilograms of raw materials. This highlights the substantial physical resources embedded in our digital technologies. Eventually, AI hardware reaches the end of its useful life. It might become outdated due to rapid technological advancements or simply wear out. This old hardware then becomes electronic waste, or e-waste. Data centers, with their constant upgrade cycles, are significant contributors to the growing global e-waste problem. E-waste is a serious environmental concern because it often contains hazardous substances. These can include heavy metals like mercury and lead. If e-waste is not managed and recycled responsibly, these toxic materials can leach into the environment, harming ecosystems and human health. The entire life cycle of AI hardware, from mineral extraction to disposal, carries significant hidden costs. Section 7: AI as ally, a glimmer of green potential. Thus far, we have focused heavily on the environmental problems associated with AI. Its significant consumption of energy, water, and raw materials paints a concerning picture. However, it is important to recognize that AI is a tool. Like any tool, its impact depends on how it is used. Artificial intelligence also holds considerable potential to help us address some of our most pressing environmental challenges. This is the other, more hopeful side of the AI story. Scientists, environmental organizations, and even some businesses are now exploring these positive applications. One promising area is the use of AI in monitoring and mitigating pollution. For example, the United Nations Environment Programme, or UNEP, is already utilizing AI technology. They use it to detect methane emissions from oil and gas installations around the world. Methane is a potent greenhouse gas, much more effective at trapping heat than CO2 in the short term. AI algorithms can analyze satellite imagery and data from other sensors. This allows for the rapid identification of methane leaks, enabling quicker repairs and reducing emissions. This is a tangible way AI can contribute to climate change mitigation efforts. AI can also be a powerful ally in efforts to monitor and conserve biodiversity. Biodiversity, the rich variety of life on Earth, is crucial for healthy ecosystems and human well-being. But it is currently under threat. AI systems can analyze vast amounts of ecological data. This includes camera trap images, acoustic recordings from forests or oceans, and satellite data of habitats. For instance, AI can identify different animal species from their calls or images. It can track changes in their populations and distributions over time. AI can also help detect illegal deforestation or monitor the health of coral reefs. This information is vital for conservation strategies. Despite these positive potentials, we must proceed with caution and awareness. Even when AI is deployed for environmental benefits, the energy and resources used by the AI system itself still matter. There's also the risk of unintended negative consequences. For example, while AI could optimize traffic flow, widespread adoption of AI-powered autonomous vehicles might lead to more vehicle miles traveled, potentially increasing overall emissions. Furthermore, a comprehensive dataset on AI's full environmental impact across all its applications is still lacking. Using AI as an environmental ally requires careful planning, ongoing assessment, and a commitment to responsible development and deployment. Section 8. Navigating the Maze. Policies for a Sustainable AI Future. The growing awareness of AI's environmental impact is prompting discussions among policymakers, researchers, and industry leaders. As of 2025, there is a clear recognition that the rapid development of AI needs to be managed responsibly. This includes addressing its carbon footprint and resource consumption. Thoughtful policies and robust regulations are essential. They can help guide the AI industry towards more sustainable practices. The goal is to foster innovation while ensuring that technological progress does not come at an unacceptable cost to our planet. Many experts believe that proactive measures are needed now. A significant 2024 issue note from the United Nations Environment Programme, or UNEP, outlined several key recommendations. It emphasized the need for standardized procedures to accurately measure AI's environmental impact. It called for companies to be transparent and disclose the environmental consequences of their AI products and services. The report also stressed making AI algorithms themselves more computationally efficient. Furthermore, it advocated for promoting the recycling of water and hardware components in data centers, encouraging the use of renewable energy sources and carbon offsetting for data center operations were also highlighted as crucial steps. Researchers are also adding their voices to the call for structured oversight. A study from Zhejiang University and Nankai University, based on data from 2020 to 2024 and published in November 2024, underscored this urgency. The researchers argued for the necessity of standardized emissions limits specifically for AI systems. They suggested that regulatory measures such as emission caps could incentivize the AI industry. These incentives would drive the adoption of energy-efficient practices. They could also spur innovation in developing new, more sustainable AI technologies. Dr. Meng Zhang, the lead researcher, emphasized balancing AI innovation with environmental responsibility. International efforts to address these issues are beginning to take shape. Over 190 countries have adopted non-binding recommendations on the ethical use of AI, which include environmental considerations. Both the European Union and the United States have initiated legislative efforts. These aim to mitigate the adverse environmental impacts of AI technologies. Experts like MIT Professor Elsa A. Olivetti have stressed the importance of a holistic approach. They call for a comprehensive consideration of all environmental and societal costs. This ensures that the benefits of generative AI are carefully weighed against any environmental trade-offs, promoting truly sustainable progress. Section 9. Conclusion: Recoding Our AI Relationship with Earth. Artificial intelligence undoubtedly presents a complex duality regarding its relationship with the environment. On one side of the coin, AI offers incredibly powerful tools. These tools hold the potential to help us tackle some of the world's most formidable environmental problems. We see promising applications in combating climate change, such as optimizing energy grids. AI can aid in preserving biodiversity by monitoring endangered species. It can help manage resources more efficiently. This potential for AI to contribute positively to environmental sustainability is a source of considerable hope and excitement for many. However, on the other side of that same coin lies AI's own substantial and rapidly growing environmental footprint. The sheer amount of energy required to train sophisticated AI models is staggering. The continuous power needed to operate these systems daily adds an even larger burden. Data centers, the homes of AI, consume vast quantities of electricity and precious fresh water. The specialized hardware essential for AI relies on the mining of finite rare earth elements. This hardware eventually contributes to the escalating global problem of electronic waste. These are undeniable material costs. The path forward requires us to find a delicate but determined balance. We must strive to develop and deploy artificial intelligence in a truly responsible manner. This means a concerted effort to make AI algorithms and systems far more energy efficient. It involves a decisive shift towards powering data centers with renewable energy sources. It demands designing AI hardware for longevity and recyclability. Crucially, it also means fostering a culture of transparency, where the environmental impacts of AI are openly reported and scrutinized. Everyone involved, from AI developers and corporations to policymakers and individual users, shares this responsibility. To navigate this complex terrain, we urgently need robust policies and clear enforceable regulations. Standardized methodologies for measuring AI's environmental impact are a fundamental first step. Such standards will allow for accurate comparisons and effective target setting. Clear guidelines can steer the AI industry towards innovation that is not just powerful but also sustainable. The global call for a more responsible and earth-aware approach to AI is growing louder. By working collaboratively and making conscious choices, we can aim to harness AI's transformative power. We can do so while safeguarding our planet for current and future generations.